Yes. Is that okay? I'm not going to fall. I'm an elite athlete. So easy. All right. Welcome to library today, kids. Library was my favorite class when I was little. Do you remember that? Like, I can't sit this way. That hurts so bad. Mr. Goddard gave me this book today.
Oh, poor baby.
Okay, so quiet children. Quantum physics for babies. Now, I know that usually F sounds like an F, but sometimes it's a P. Right? Are we okay with that? Quantum physics for babies. This is a ball. I'm smiling, and I'm very uncomfortable smiling. Do I look okay? It's so abnormal. This ball has energy. Funny timing. I've never done this before. This is a ball. But this ball has no energy. Wow. All balls are made of atoms. No 12-year-old jokes. This is for babies. They're not inappropriate yet. These are neutrons. See him? See right there in the middle? Okay. He's a baby. Next. And we have protons as well. And where do they live? Class? Students? Children? They're in the middle. We're children.
Oh, sorry.
We're babies. They're in the middle. And we have a name for that. It's called the nucleus. Okay. Then this ball has electrons. Actually, they always would hold them like this. Right?
Why don't the ones in the middle go out to the sides?
I can't answer that. Shut up. We'll maybe get that. The electrons can be here. Or you're a baby. Or here.
What? No way.
But they can't be here.
Oh, okay.
Because they don't exist. I don't know, because I'm not in their forest, so I don't know. All right. Or here, meaning they can't be in between and they can't be in the, what do we call it, class? Nucleus. That's our vocabulary word for today. Look at your partner and say nucleus. All right. Did you know that inside every man is a nucleus? No one's seen Nacho Libre ever? Okay, I'm showing you that next. So I'll get fired. All electrons have energy. This electron has the most energy because it's the farthest from the nucleus. So if it were to fall, it'd fall the farthest. Yeah. Wow, you guys are getting it. This electron has the least energy. Now, let's pretend this is for AP students. This one would have the highest what? We learned this binding energy. They would be reverse of each other, right? This one has the most energy to give off as it goes in, but it'd be the easiest to remove. Yada. Back to babies. All right. An electron can take energy to jump up, and it can give energy Tell your partner what you think. To go down. Now you are a quantum physicist. Okay, well, there we go. I feel awkward now. Back to grumpy.
I think it's
Nap time. We don't have a carpet to lay on with like numbers and colors and stuff like that. All right, so, whoa, Nathan's on Zoom. So one day to be on Zoom is today. I'm sorry that I didn't zoom in on the Physics for Babies book, but okay, my friends. Today we're going to do a lab. Sound fun? In this lab, we're going to add energy to electrons. Tell your buddies what's going to happen to the electron if I add energy to them. They're going to jump up, right? Now, time out. Excuse me. We had said that they used to live on circles. And there, I mean, this book. Oh, don't fall, Tom. This book represents them as orbits. We really call them orbitals. And instead of jumping up in orbit and falling back down, which is a lot easier for us to like contemplate, it's going to go from being one shape to a smaller shape, or a small shape to a big shape, or a different shape, right? The math is the same, but we're going to see evidence of that today. Easy enough? Okay, I'm not even going to make you write a single thing down for this lab. You're welcome. But we have a test tomorrow. Well, I didn't really have a but. Okay, so we're just going to do it for fun and kind of look. And it's pretty easy. There are some things that are dangerous. What did you need, Safalo? She hasn't texted me yet. It has to be done by 2, she said. Like, no matter what, it will be done by 2. I will not, but Jesse probably can figure something out. All right. Do you have a prep hour? Do you have Mary Ann's number? Braithwaite? Sure. Okay. Yep. All right. In this lab, and Nathan, this won't be super exciting, but whatever. It's okay. First hour was boring, apparently. Okay.
Actually, no, it wasn't. It was
Actually, she's being over dramatic again.
It was so, yeah. We did skits.
Did I say that out loud? I just need the right one. Oh my. They enjoyed the book.
They enjoy the book?
Yep.
Oh, you want more? I got more of those.
Yes, please.
What? Sam Davidson reads them all. Which one? All of them. All of them.
All right, here we go. Will you get all these and move them all to that table? Then we'll figure out. Yep, right here. Okay, my friends, let me get this stuff real quick and we'll get partying. Goddard, would you do me a favor and get the spinning green thing?
Yeah.
Thank you.
Do you want a corner?
Sure. All right. Look at me. All I do is complain we're behind, and then I have story time. What kind of teacher am I? Don't answer that. All right. X, will you hit the lights for me? On the what? Respected?
Yeah.
Really?
I mean,
Probably my. That's valid. Okay. We don't want the outside world to know we're playing with fire. Okay. Shh, shh, shh. Why are you making noise? Okay. You don't have to write anything down. You come back here. This says strontium chloride. Okay. Look over here, please. You take this and you put it in this flame and lower it down, and the flame will turn a different color. So that's strontium. When you go to put this back in, be careful. You can burn yourself pretty solid unless you put it into the tube. Some kids put it right here, including Tom Davidson. All right, so that was one color. This is about the same one, honestly, but they're not all the same one, I promise. Okay. Here we go.
They're not all the same.
They're not. All three of those were different. Did they look different to you?
Slightly.
Not really. Okay. Okay, that one's different, right? Okay, put that back in. Now, so one of you will dip that and put it into the fire. We okay with that? Hit the lights again for me if you would. Now they all looked, not all of them, but they looked pretty similar, right? But they're different, I promise. We're going to look through one of these. This is called a spectroscope, and it's like a prism, all right? The light comes in this tiny slit that someone put too close to the flame. Don't do that. Like, you want to be pretty close, but not in it like that person was. So far, okay? Okay, so you're going to, and the lights are on, so I won't see anything really, but you would line this up with the flame. And when you look through this, you'll see the light right here, and then you'll shift your eyes. Now, just your eyes, not the thing. Just your eyes. You're like, oh, I'm going to look there, and then I'm going to go here. And there's a grid of 4, 5, 6, and 7. Any guesses what 4, 5, 6, and 7 are? Wavelengths. It's 400, 500, 600, and 700 nanometers, right? That's literally the visible light that is given off by this atom. Now, almost all of them will have a really bright orange line. And that's because all of them have the same piece of metal that they're being burned off of. Be patient and just kind of keep staring at that line. There's more than just a bright orange line. They're super subtle. I'm aware of that. But Mr. Goddard's putting up, let me correct myself. My lovely assistant is over there. He's putting one that is through a gas. Which one worked?
I should work.
Did any of them work then? Consistently?
I can't get air to work.
All right, turn one on for me.
Oh, see, now air is working.
Okay, so can you see that line over there?
Yep.
That is air trapped in a tube that's being electrified. So its electrons are bouncing because of electricity. That is much more pure and accurate than a Bunsen burner with a piece of nichrome wire in a dirty test tube. You okay with that? So make sure you look through that and you'll see lots of defined lines. And those lines you may remember are given off when electrons are excited and then they fall again. Every single atom has a different fingerprint or what we call spectral line or spectral lines. That was bad English, but they have their own spectrum and their vertical lines. Now also, bless you twice. Okay, I'm usually a 3 sneezer, but I was also a 2 sneezer too. Maybe we have the same thing. Okay, also at some point in time, sorry, I'm weird. At some point in time, just look up at white light. These won't be on. You can go out and look at the skylight. You can go, well, I'm gonna have my blinds down, but just look at that and see the rainbow. And it's really pretty cool. You'll see a continuous spectrum, when you look at white light. You will see a non-continuous or discontinuous spectrum when you look at these. Kind of all right? Okay, if you have long hair, please tie it back so you don't light it on fire. This is, I used to make you do math, and we'll do math together, but I'm not going to have you like turn it in. So we're not going to write it down. Okay, so let's take 15 minutes. Let's light some Bunsen burners. Let's check these things out. Make sure and look at the one in the corner just to kind of experience the what we call spectral analysis. Okay, ready, go. Yeah, I don't know what's wrong with that thing. I'm not going to put one here. We'll call that good enough.
Yeah, I have it on nitrogen now. It was working.
Okay. Yep. You need a spectroscope there. Some are better than others. Hey, listen real quick. We're not going to use this station here and then just share. There's only 1, 2, 3, 4, 5 sets of them, but that can be 10 groups. And not every single person needs a spectroscope, just a person in each group. And we're just looking, and I'll turn this on.
Where's all the...
No.
Yeah. Hey, you don't have to wear safety glasses unless you want them. You don't have to have glasses. Okay, the lights in here are going to go off. 5, 4, 3, 2, 1. Okay, start lighting your Bunsen burners and heating those stuffs up and look at those. Have we never used a Bunsen burner before in this class?
I'm still trying the...
There you go. And then put it in the sink.
No, put it on the table or get it wet. That's fine, but don't leave it in the sink. You not feeling good, my friend? Not feeling good?
What?
You're not. Hey, the one is on in the corner. So if you're not looking at one now, walk over to the corner and look at that. And that is actually called argon. Be real careful. No, you psycho.
Can I blow it out before it touches my fingers?
Yeah, of course.
Nicely done. Lick it. Get it away from you. Davis, we're starting without you.
If you're on this side of the room, look at the light away from the window, or all you get is that light. So Brittany, so you guys move this way. Oh, you got well, you both do. You just one of you away from that ambient light.
And we're supposed to say the number that comes here.
Yeah, you're just looking.
Oh,
Well, that's normal. Nothing.
That was so scary.
Hey, one thing real quick I should say. Don't tip the test tubes. If the liquid rolls onto your finger, you can burn yourself. So keep the test tubes vertical. I hope it's going all right, Nathan. I don't know if you can tell on the camera that they're changing colors. Oh yeah, you can. You don't need to do anything for the lab. Just kind of sit and enjoy. Yes. Did you burn yourself? Okay, I can get you a different one. Hey, if you want to put 1 or 2 or 3 or 4 in at the same time, that's fine. Just keep track. Like, make sure you know which one. There you go. This one, if it starts to spark like that, then you just move it. There, just grab the top and then like push down.
Wait, do it again, sorry.
So grab this,
okay.
and then if you push down, because if you grab this and pull,
Yeah,
you'll squirt your
squirt
face.
at me.
Yep. Yep. Nothing here besides bleach.
Okay.
Nothing's dangerous. That's why we waited. A little copper and a little bit of, what's the red?
So what's the gas?
That's methane or natural gas.